An important goal of science is to make societal impacts. We want to understand how the world works, and we want to provide important recommendations on how we can solve societal issues. We, as researchers, are also expected to conduct objective and vigorous research which would allow us to provide such recommendations. And an important characteristic of rigorous, objective research is that it is replicable. A study is replicable if I, as a researcher, find something with a certain design and a certain sample, and another researcher finds the same thing with a similar kind of design and a similar sample. And replication was quite common in other fields already. So for instance, in the field of medications, you really want to be sure that if you launch a medicine on the market, that it doesn't have any negative side effects. So it's really important to have replication studies to test this. In the field of psychology, however, it was way less common to conduct such replication studies. It only recently really was done in profound ways. And the results of these replication attempts were alarming. It was found that up to 70% of the findings in psychology were unreplicable. And even if a significant effect was reproduced, it was way less high in effect size. So we are facing a replication crisis in the field of psychology. Published results may be hard to replicate because of various reasons. First of all, in the past and maybe even nowadays, journals want a clean and impactful story. If you have non-significant results or findings that might be hard to explain because they are a bit counterintuitive, they are hard to get published in a journal. This is commonly known as the publication bias. So it could be that several other researchers detected no significant effects, but they simply could not get their paper published. It could also be that the significant findings in previous work are false positive findings. So researchers may have thought that they discovered an effect, whereas actually there was no effect. And this may have happened because researchers consciously or unconsciously steered their findings towards a positive, towards a significant effect. And they could have done this, for instance, by the process of harking. If researchers hark, it means hypothesizing after results are known. They first go to their data and they check whether there are significant associations. And if there are significant associations, they start to act like they already expected them to happen. So they make a kind of hypothesis about the significant effect that they found. But yeah, they already had the effect. So actually, well, there was no hypothesis up front. That could be one practice that may have caused that certain significant effects that occurred were just presented in the literature as if they were hypothesized effects. And this is problematic because in a large data set with many variables, you always will find a significant association. Your type 1 error, the chance that you will have such an error just increases. So this is problematic and can create false positive results. And then there's also the process of p-hacking. It could be that, for instance, a researcher has a hypothesis and collects data, analyzes the data, and sees that the result that they are interested in is almost significant. And then a researcher often has a lot of wiggle room, I would say. They can make kind of arbitrary choices, also referred to as researcher degrees of freedom. And if they make these choices, they can try to get this p-value below 0.05. So they could, for instance, add a covariate to the analysis, or make sure that they have a slightly different selection of the sample. Or maybe they want to adjust their measures a bit, just kick out one item. And by trying out all these things, they may eventually end up with an effect that is significant. And yay, they have a study that is way easier to get published. And maybe it could also be that researchers are just doing this because they believe that the effect that they find, or that seems to be almost there, is really meaning something. But of course, if you really have to try so hard to get your p-value below 0.05, you have to wonder, like, is this a real effect? And of course, these practices, these questionable research practices, are undesirable. If findings are not replicable, how should we be able to provide good recommendations for practice? And in order to eliminate such practices, it has been argued that researchers should write a pre-registration before they conduct their study. What is a pre-registration? Well, a pre-registration is a time-stamped document, so it is clear when you made this document, in which you specify your research plan. It can involve your hypotheses, your research question, your measures, and also your analytic design. This document ideally is prepared before any data has been collected. Sometimes that's not feasible because you have a longitudinal project, but then it is ideally prepared before you had a look at the data. And then it is uploaded to an online repository. And you have several online repositories for this. You have OSF, the Open Science Framework, or As Predicted, and they guide you through this pre-registration process. They ask you questions like, oh, what will your sample be? What will your measures be? You can also leave fields blanket if you are not certain about it. And in this way, you can pre-register your study. And it will become public, either immediately or after a certain embargo period. And there are actually two types of pre-registration. So you have this unreviewed one, the one that I was already talking about. So you go to OSF or As Predicted, you answer to the questions and you pre-register your study. And then you start collecting your data, analyze it, and hopefully it gets published. There's also the type of a peer-reviewed pre-registration. And this implies that you just send out your introduction and your method section to a journal. And then the journal sends it out for peer review. So your introduction, your idea, and your methods, so your measures and your analytic plan, are already being reviewed. And this is of course great because then reviewers already can think along in hypothesis formulation. They can even provide advice for the data collection or for your measures. So then you have your first steps basically already peer reviewed. And if you are able to appropriately respond to the reviewer comments, the editor of the journal can provide an in principle acceptance. So the editor basically promises you, like, irrespective of the results, I think that you have a great study. I am willing to publish it no matter what the results will be. So then you are much more certain that your study will get published even if you have non-significant findings. And the use of pre-registration has grown enormously. It was already considered to be important in other fields, such as clinical trials. That was even already before the year of 2000, and after years of 2004, it even became obligatory to first pre-register your clinical trial and then conduct your study. Well, in the field of psychology, it's not obligatory, but you can earn a badge. So if your paper is being published, you see a badge on that paper which indicates, like, hey, this researcher pre-registered this study. So these developments are showing that pre-registration is increasingly becoming a common practice in science. And it's even considered as a necessary and rewarded component. Why? Well, it has been argued that pre-registration can prevent the questionable research practices that I talked about. One thing that pre-registration, for instance, may prevent is harking, hypothesizing after results are known. If researchers pre-register their ideas before any data collection has taken place, it is impossible to pretend that they already theorized about the results that come up. And it also helps readers to distinguish between confirmatory research, or research questions, so the things that researchers really expected to happen based on theory, and exploratory research questions, so the things that researchers may, out of curiosity, wanted to explore a bit better. Also, pre-registration may avoid p-hacking, because if you have a clear analytic plan, if you are very clear about what measures you will use and how you will analyze your data, you are limiting your researcher degrees of freedom. So you have less room to make these arbitrary choices so as to p-hack your values. And this, of course, sounds great. And therefore, many journals decided to provide these badges because they thought, like, if people undertake the effort and the time to pre-register, we should reward it. However, the past year, quite a lot of papers have emerged that question the use of these badges. And Simin Wazir, she recently became an editor-in-chief of Psychological Science in January 2024. She even said that she wants to let go of these badges. Why is this the case? Well, the most important reason for this is that pre-registrations vary a lot from each other. So the word pre-registration actually means nothing. There are a lot of pre-registrations that are very, very vague, and there is today no structural way to determine the quality of a pre-registration and to compare a pre-registration to the eventually published paper. Is there a correspondence between the two? So pre-registration does not in and out of itself refer to quality, and a badge may misleadingly suggest that this is the case. And because of these reasons, it has been questioned whether pre-registrations are really the way to go, and also the way to prevent the questionable research practices that I referred to. For instance, in a very recent study, Van den Akker found no scientific evidence that pre-registration would prevent harking. And in another study, Van den Akker found that about half of the pre-registered hypotheses were not found in the published papers. So about half of the pre-registered hypotheses magically disappear. And about a fifth of the pre-registered hypotheses seem to change in their direction in the published paper. So in the pre-registration, a researcher said, I expect that A negatively predicts B, but then in the published paper, the researcher said, I expect that A positively predicts B. So apparently a pre-registration does not hinder researchers to change their hypotheses or to drop them. And of course, you can make changes to a pre-registration. That it's really good if you discover that you should change something because you have an oversight or a mistake. But it is really important to be transparent on this, to make transparent changes and to consider which changes are really valid or justifiable. Because you also have this process parking, pre-registering after results are known. And this is also still not contingent with null hypothesis testing. So you should be really aware of what you are doing if you change things as compared to your pre-registration. Furthermore, you could question whether a pre-registration really helps you to distinguish between confirmatory and exploratory research. For example, what if a researcher thinks I think that A predicts B, and I have theory for this. So that's confirmatory. But I also want to explore whether A predicts C. I don't have any theory, I don't know of it, I will explore it. Then the researcher discovers that A indeed predicts C. And the researcher goes back to the literature and then suddenly discovers a paper that already said, like, yeah, it is very likely that A will predict C and there's a lot of theory. But the researcher didn't know about that paper when they started their study. Then, is the test that the researcher conducted, is it exploratory or is it confirmatory? Sometimes it's really a fine line. Also, there's not only a replication crisis, but there is also a theory crisis. There are a lot of vague theories. So even if you use a theory, and if it's fake, then you can maybe endlessly stretch it so that it seems that your results are confirmatory, whereas maybe you're just using a vague theory. So pre-registration will also not put an end to this. Lastly, it was assumed that pre-registrations would diminish the researcher degrees of freedom. A recent study of Brodeur of 2024 found that this unfortunately was not the case. But this was particularly not the case because a lot of pre-registrations were vague. But when they had a clear analytic plan attached to their pre-registration, then it did help to prevent that p-hacking occurred, and it did diminish the researcher degrees of freedom. So it is important to have a clear and detailed analytic plan. So apparently pre-registration does not mean that questionable research practices are banned. And as long as there's no clear system that enables to assess the quality of a pre-registration or that helps to check for the correspondence between the pre-registration and the published paper, I indeed think that this pre-registration badge does not add that much. However, this does not, by no means I want to say that pre-registration is not useful. I think pre-registration is very, very useful. It helps you to be transparent about your ideas from the start. It also helps you to think better about your ideas, and you can even get peer feedback from it. It can be peer reviewed. It also helps you to be more accurate in what you expect. And you can also think out how you will analyze it and try to diminish your researcher degrees of freedom as much as possible. So I really would encourage researchers to do it, to pre-register their study, not only for themselves, but also because indeed there are also other studies that show that pre-registration can eliminate the excess of false positive results. As I said, this study of Brodeur found that as long as you have a clear analytic plan, that then indeed p-hacking and, well, this excess of false positive results can be prevented. So for this reason, I think that researchers should definitely not be discouraged to do a pre-registration. And even if you don't know everything, or even if you have like a kind of exploratory research question in mind, a pre-registration is better than nothing. And open science also starts with baby steps. So please start practicing it. It helps you to clean up your mind. It also helps you to remind you of your initial aims. So pre-registration is always good. It is also quite common that people are afraid of doing a pre-registration. What if I make a mistake? Or what if I really have an oversight? Should I then still stick with my pre-registered plan and it will be open to everybody? Well, I want to say, please don't be afraid, because I think all of us make mistakes. We are not perfect. We are human beings. We are scientists, but we are human beings. And I think that it's better if you are just trying than when you're not trying to do it, because we can also learn from each other and from our pre-registrations. That is basically team science, and that is the culture that we want to go to. So, to sum up, pre-registration is good and useful, but it is not a perfect safeguard. And in my opinion, a registered report, that would be good to be the golden standard, but I have to admit that sometimes it's quite hard to have your introduction and method fully peer-reviewed before your data collection can start. So we really also need to consider what a registered report should look like and how to define it. Also, with regard to pre-registration, we need that people are being trained to write a pre-registration. We need the tools so that pre-registrations can be properly evaluated and compared to the published results. So we should keep learning, also from other fields that have been doing this for much longer. So let's see where we're at in a decade.